Welcome to my lecture on ballast tanks. Today, we'll explore the functionality and construction of these vital components in ships. My name is Dr. Sam Tawfiq, and I'm excited to share this information with you. Introduction to ballast tanks. Ballast tanks are essential for maintaining the stability of a ship during its voyage. These tanks help manage the weight distribution, ensuring that the vessel remains balanced in various sea conditions. Ballast tanks are introduced at various locations for maintaining the stability of the ship during the sea voyage. Functions of ballast tanks. Ballast tanks serve several critical functions. First, they help reduce the stresses on the hull of the vessel, which can extend its lifespan. They also enhance transverse stability, keeping the ship upright. Moreover, ballast tanks ensure that the propeller remains submerged and that the rudder is sufficiently immersed, which is crucial for maneuverability. In other words, we can say that the functions of ballast tanks are: reduce hull stress. Ballasting helps in reducing stresses on the ship's hull. Improve stability. Enhances transverse stability of the ship. Submerge propeller. Keeps the propeller submerged for efficient operation. Support maneuverability. Helps immerse the rudder, aiding in maneuverability. Classification of ballast tanks according to ship's type. The following slides will categorize ballast tanks based on the specific type of ship they are installed in. This classification is crucial for understanding the unique requirements and functions of ballast tanks in different vessels. 1. Ballast tanks in bulk carriers and general cargo ships. This image illustrates the location of ballast tanks in bulk carriers and general cargo ships. Top side tank, positioned at the top of the ship's hull. Hopper tank, located within the cargo holds, often used for bulk cargo storage. DB tank, situated within the double bottom of the ship. 2. Ballast tanks in container ships and oil tankers. This image illustrates the location of ballast tanks in container ships and oil tankers. Side tank, positioned along the ship's sides. DB tank, situated within the double bottom of the ship. 3. Ballast tanks in roll-on, roll-off ships. This image illustrates the location of ballast tanks in roll-on, roll-off ships. DB tank, double bottom tank, situated within the double bottom of the ship. Location of peak tanks on a ship. All ship types, regardless of their design, incorporate peak tanks for added stability. This image illustrates the location of peak tanks on a ship. Aft peak tank, located at the stern, rear, of the ship. For peak tank, situated at the bow, front, of the ship. Structural components of a ship's double bottom. This image illustrates the structural components of a ship's double bottom, which is a key element in ship construction. The double bottom consists of 2 layers of plating, separated by a space that forms a series of tanks. These tanks are used for various purposes, including carrying ballast water for stability and fuel storage. The image highlights the following components: tank top, the upper plate of the double bottom. Solid floor, a transverse plate that supports the tank top. Bottom plating, the lower plate of the double bottom. Girders, longitudinal beams that provide structural support. Bracket floor, a transverse plate that supports the girders. Inner bottom longitudinals, longitudinal beams within the double bottom. Intercostal side girder, transverse beams that connect the inner bottom longitudinals. Continuous center girder, a longitudinal beam that runs along the center of the double bottom. The double bottom plays a crucial role in a ship's strength, watertight integrity, and overall structural stability. It also provides additional protection against grounding and collision. Construction of double bottom tanks. Double bottom tanks are a common construction method for ballast tanks. They provide added safety and stability, creating a space between the ship's hull and the water below, which helps manage the vessel's buoyancy. Components of ballast tanks. Now, let's look at the key components of ballast tanks. First, we have the pipelines, which are crucial for transporting liquids in and out of the tanks. The bell mouth serves as the inlet and outlet for these liquids. For maintenance, the manhole provides access for inspections. Sounding pipes are used to measure fluid levels, while it's equalize pressure within the tank, preventing potential damage from over or under pressurization. 1. Pipelines and bell mouth. Pipelines are used to carry liquids in and out of the tanks or bilges. Bell mouth is used for inlet or outlet of liquids inside tanks or bilges. 2. Manhole. Manhole access to the tank through which a man can pass for inspection or maintenance of the tanks. 3. Sounding pipes. Sounding pipes are small bore steel pipes used to measure the quantity of fluid in a tank or a hold bilge. 4. Air vent. Air vent is a pipe provided to equalize the tank pressure with the atmospheric one while the tank is being emptied or filled. It protects tanks from filling up with seawater or being overpressurized or underpressurized. 5. Air sounding system. This image illustrates a common method used to measure the fluid level, specifically in a ship's ballast tank. This method is often referred to as sounding. Here's how it works. Sounding pipe. A vertical pipe is installed in the tank, extending from the top to the bottom. Sounding tape. A graduated tape, marked with depth measurements, is attached to a handle or reel. Striker. Datum plate. A small plate is fixed at the bottom of the sounding pipe. To measure the fluid level, lower the sounding tape into the pipe until it is the fluid surface. The point where the tape touches the fluid indicates the depth of the fluid. The depth reading is taken from the tape's markings. This method provides a simple and effective way to monitor the fluid level in the tank. The air vent at the top of the pipe allows for pressure equalization, ensuring accurate reading. Conclusion. In conclusion, ballast tanks play a vital role in maritime safety and efficiency. By understanding their functions and construction, we can appreciate their importance in ensuring ships remain stable and maneuverable at sea. With my best regards, Dr. Sam Taufik.